Okay, so I want to record a short video showing how I've been making some of my recent animations I've made. Because I have this huge programming project which I call BBM, short for binary bitmap, although it can do other colors as well. So I'm going to record my screen and I'm going to show you how this works. So I have, am I recording? Yes, okay. So I have several source files here. Now, they all do different things. Some of them do basic things like outputting images to certain formats. Now, and some of them are unfinished code that doesn't do anything that I haven't finished. But today I'm going to be focusing specifically on two files, main.c and bbm polygon.h. Okay, so need to get both of these files open here. And I use Notepad++ just because I'm used to it. So here's the thing. The star test function is, the star test function is called from the main function. Now the main.c file includes all the headers that are relevant to what I'm currently doing. So it calls the star test function. Now the star test function is a function I wrote. I have, for example, I have a polygon test function. There's certain functions I've written. I wrote most of these recently. So here's what I want to show you is the star test function is actually fairly large. Now what I want to do here is I'm going to set the frame max to 1, and you'll see why this is later. I'm going to temporarily take that from, I'm going to copy that from that comment, so the frame max will be 1. And I'm going to show you what this does. So the files, the output files are always saved to the folder named O. I use O as short for output, just like I have an I folder that has input files. So sometimes there's certain files that I have my program read just to test certain functions. But most of the time I'm outputting something. So now there's no files in this folder here. But now I change directory to BBM, and see here all of my source files are in here. Now when I type make, here is what happens. And you'll in fact I can explain. See, this command, it compiles the main.c source file, saves an executable named main, and then it runs it. It's a very simple, I use that command all the time when I'm doing programming. Now there's a whole wall of text here. What does all of this mean? Well, first of all, it shows it's making points for a regular polygon with 5 points, and it has this long command there that it does. And you see the name of a bitmap file here. So there's a lot of detail here, and it all means something. All this text is output by various code that I wrote. So now if we go here, we see there is a file in this folder where there was not before. Okay, what do we have here? Okay, yep, and there it is. There is a pentagram. It's a 5-pointed star. And it's actually very interesting how this works. You probably wouldn't guess how this program actually does this. So let me explain how it works, and then let me show you how I can modify this for all kinds of purposes. So I'm going to go back. First of all, I also want to show you my make file. My make file is the one that has that command that compiles and runs the code, and I have various other make targets because I learned how to write make files. It's not too hard to do, honestly, and there's advanced features I don't know about. But enough about that. So what is it actually doing when it calls the star function? The star function is what is responsible for drawing those pentagrams that you just saw. So there's several variables. This is a huge demo function. Notice that the number of points is 5, and the radians is the rotation in angle in radians. It's a weird thing. And then frame and frame max are used for my animations. Now, if it's just a single image I want to create, I set the frame max to 1. But if it's more than that, then I do more. And notice how here it says frame max is 360 divided by the number of points. That's because 360 degrees in a full turn divided by the number of points. That becomes important later because there's a lot of code here. Like this huge wall of code here that you see it does some very fancy stuff that you probably wouldn't understand if I tried to explain, unless you know about bitwise operations and what XORing means, exclusive OR. Now I'm going to show you, for example, actually what I'll do is this part of the code only happens if that value is not 0. So let's try running the program again and then see if it does anything when that value is 0. Okay, we have a file here, but it's only showing the small star. Yes, that's because it has not been XOR'd with the others. And so I can do various things. By changing the XOR thing, I can add or remove certain parts. For example, if I remove this part and then rerun the code, the image will be different because there's actually 3 different images that are being merged together to create the final result. This is when we have the big star and the small star inside each other, which is actually really kind of cool looking. I could totally do something just with that. And then I'll show you something even crazier. If I change which pointer, there are 3 pointers. There's P, there's P1, and P2. P is just implied to be P0. So let's say if I change this to just P, what will it do? I'll show you. The P pointer, which I call P0 also informally, is just the checkerboard. When it outputs that pointer with the width and height value, it's just a checkerboard. So you see the original image. I'll show you that again. So what it's doing is it's taking the 2 differently sized stars and a checkerboard and it's exclusive ORing them all. So that's how we get this. Now we can change the number of points. That's what's exciting about this. So let's change the number of points to 4. And let's see. Okay, okay, here. Oh, here it is. Number of points. Let's change this to 4. So, all right. I need to rerun the program now that I have changed that one variable. All these variables are hard coded. If I tried to make it so that these were input by a user, well, there's too many variables. You see, because they would have to put in the number of points, the degrees or radians of the turn, and then some of these are not input by the user, they are temporary variables, and it saves to the Microsoft bitmap format, and it's actually my own code that I wrote that creates the bitmap format. But anyway, let's see what we have here. That is so weird. Now it's not showing anything. I think I know why. I think that's, wait, did I do something wrong here? That's strange. For some reason it's not showing anything. I think I must have made a mistake. Okay, that's weird. Why is it not showing anything? Oh, I think I know why. Because it doesn't know how to make a. Oh yeah. Oh, I think I know what's wrong. Oh, okay. I'll show you something else. Now, there's something else. There's a step value. So, for example, the star is function. It makes star polygons, and I was trying to make just a regular polygon. So let me show you something. Let's say if I change the step value to 1 for the larger star, and we'll have the number of points still be 5. This is a little mistake I made that I did not foresee coming. I did not want to open the stupid Windows Store. I have it there that I got for convenience, but I clicked on it accidentally. Now we see just a regular polygon. And see, here's something, I want to show you a little something. These long, complex commands, it's calling the image magic program. And it sets the canvas to black and the fill to white, and it draws polygons with certain points. And I wrote code that does all that. But why? So now we have this big regular pentagon, and then we have the star inside of it. Well, we can also change that one to be just a regular pentagon. So let's try something. Now we have it where, notice, okay, now we have 2 regular pentagons. So I'm going to show you something. So now this program is capable of making animations. So if I remove the part where it's frame max equals 1, then I'm going to rerun the program and it's going to do a lot of stuff. Okay, and it'll run a little bit slow, but let me show you, it's actually creating a series of files. It's actually creating tons of files, and it's drawing 2 differently sized pentagons, and it's drawing the checkerboard, and it XORs all 3 of the images together, combining them, and it should stop at about 72. So let's go back to the console where it's running. And see, this program is very slow because it's doing a lot of things. For each star, it is running a command from the command line. It is running an external command to draw those polygons. And in fact, it draws a series of triangles to make the regular polygons even. But that was actually meant for star polygons. But my star functions are dual use. They have multiple purpose. In fact, let me show you something while that's processing. My star function here, it takes a whole bunch of variables. So it's actually drawing a triangle each time. It uses the several variables. So the name of the file to save to, the width and the height of the total image that is going to have the polygon in it, and then the values of the center, x and y values of the circle or polygon, in this regular polygon in this case, because all regular polygons or circles have a center. And then it has a radius. How big of a radius of a circle does this polygon fit into? Radians, the rotation of it, the number of points, how does it step through? So the points, for example, just a regular pentagon is a step of 1, but the 5-sided star polygon is where it does every other point, so it's a step of 2. So it's actually very weird, and I have this code does that. And then it has the color, but you'll notice that the color is white. And that's it. The color is white because I use black and white for my examples, because this is the binary bitmap project folder. So let's see here. The program is done. Okay, so we have 71 image files. So here's what we have. So each frame is slightly different. I can cycle through these frames with my image glass. So if I go backwards, it goes this way. See, going backwards in frames. But if I go forwards, they're both rotating different ways, and it's really, really cool. So let me show you something. In the code, the reason that they rotate different ways is that the radians value, which is changing, it's rotated by pi divided by 180. This is a formula that you'll see in other example code other people have written. And so one of them has negative radians passed as the argument. So we have a series of frames. So what do we do with these frames? Well, it's actually very simple. I'm going to show you something. First of all, I'm going to type clear my console, and then I'm going to do cat makefile. Now, if you look in this makefile, there are several things it can do. Now, it can also make videos and stuff, and it can also compile with TCC. In fact, yeah, it can do a lot of different things actually. And the SDL one, I have not used that one because none of the SDL codes still exist, but I'm keeping that there in case I need it someday. So anyway, I'm gonna do make GIF or GIF, however you pronounce it. And this runs a command to turn those image files in that directory into an animated GIF file. So I do make GIF, and it's running this command. And I've been reading a lot of the ImageMagick documentation. Hey, the command is done. So what did it do? So let's look back in our folder, and what do we have? We have a 0.gif folder file. So we see it's the same dimensions, because all the other dimensions of all the others is 512 by 512. That's the dimensions I chose. We have an animated GIF file. We actually have an animated GIF file. Is that cool or what? So we have an animation where a polygon is spinning one way and there's a smaller polygon spinning the other way. So it works, but now are you starting to see why there's exactly 72, well, there's 72 frames numbered 0 through 71. But are you starting to see why there was 72 frames? That's because 360 divided by the number of points. So 360 divided by 5 is 72. So while it's less than 72, it creates those frames. So now that I have an image animation, what am I going to do? I'll show you exactly what I'm going to do. I'm going to do what I always do. Every time I create a new animation, I have this habit of wanting to share it to all my social media. So, and it's not too hard to do. Actually though, you know what, I'll hold off on that because I just realized that if I try to log into Facebook or LinkedIn, it's going to be showing other people's posts and stuff, and then there's the issue of their privacy, and I want to respect people's privacy and their stuff. I don't want to be showing other people's posts in my video. But anyway, that's basically it. So we have an animated GIF. So that is how the process works, basically. But exactly how do I get the points for the polygons? Well, actually, there's a formula for that, and this video would not be complete if I did not show you that aspect of it. So the first function in this file, first of all, we have some variables. And these are global variables. Endpoints is the number of points that we are doing of the current polygon. And then, which is actually weird because, oh yeah, the endpoints variable, I'm not using it very often for some reason. That's very weird. Oh well, but it's fine. But it has these global arrays it stores the points into, and it does this formula. It does a floating point value initially, where the angle is, first of all, it's the I divided by the points. So the number is going to range. So in this case, the number is going to range 0 through 4. It starts out as 0, and as it's less than number of points, which is 5, it's going to do that divided by the number of points, a fraction. So 0 divided by 5, 1 divided by 5, etc. And then it does this angle thing. It takes that number and then multiplies it by 2 times pi. And it gets us the correct angle in radians. And then it also additionally adds the radians value of the current rotation that I want the polygon to be. And then it does the sine and cosine functions to get the actual numbers. Then it has to first it has to add that value to the center x and y coordinates to make sure it's centered at the right place on the screen, and then it multiplies it by the radius. So this is actually, I kid you not, this is all the math that goes into calculating the points of the polygon. And then it stores those x and y values into separate arrays, the x points array and the y points array. And if you followed all that and you actually understand trigonometry and what sine and cosine do and all that, then you're a genius. First of all, but second of all, that is the only place in all of my source code where the number pi is used and the sine and cosine functions are used. So the points function, it takes several arguments, the center, the radius, the radians of rotation, and the number of points, and it stores into that array the number of points it stores all those points into those arrays, and that is how they're used. So for example, in my polygon function, it starts out a command and says, here's the canvas size and color and fill color, and then we're going to draw a polygon, and then it does all of those points. It's basically pulling the x and y values from the array that's already called by the polypoints function. So the polypoints function is called in the polygon function and the star polygon function. Now, what is the difference between the star polygon function and just the regular polygon function? Well, actually, I'm done showing you source code, so I'll explain this. So the star polygon function draws a series of triangles, and it draws a series of triangles in order to properly fill the star polygon and make it look the exact way I want, because I'm very picky about the way I want my star polygons to look. But just the plain old polygon function, it draws a regular polygon, but it cannot make star polygons. But the advantage of just the simple polygon function is that it doesn't draw a series of triangles. It only draws all of those points as one polygon. So that means it only is calling the ImageMagick command once instead of times the number of points. So instead of calling it 5 times, it's only calling it once. So in other words, the simple regular polygon function is 5 times faster in that case than the star polygon function. But keep in mind, just because the program runs slow, because this is the current workaround I have for how I make my polygons, doesn't matter, because when the animated GIFs are uploaded to the internet, they're portable and viewable on people's phones, on people's computers with Windows and Macintosh, Linux. They can view those animated GIFs on all these social media sites, and it doesn't matter to them how long it took my program to generate it. So that simple animation I made in this video, even if it took me an entire hour to generate the frames, it doesn't matter, because it only takes a few seconds for the image to load and animate on somebody's Facebook page. So graphics programming is rewarding. Graphics programming is more rewarding than any type of programming I've done because it gives me something that I can say, look, I made this. I have all this code and I'm finally using it to make these cool things. So as you can tell, I'm very excited about graphics programming and my binary bitmap project. So if anybody is wondering what my programming is about or what the binary bitmap project is, this video should give you a taste about what it is that I actually do. I basically draw polygons and checkerboards and I make these cool things of beautiful black and white art, sometimes animated like in this case. So anyway, that's all I have the time and energy to say for now, and I want to get back to my programming and making other animations. But I hope you've learned something from this and enjoyed it. And ask me any questions. If you have questions about how to get into graphics programming or how something works, hey, maybe I can help a newbie programmer out. I'm very busy, but I'd like to try because programming is not easy to get into if you're a beginner. And I've read so many books and tutorials and I've experimented around, but it's not easy to really get in there and start making things. I didn't find it to be easy. Some people are more naturally talented than I am, but I'm not talented. I'm just persistent.